The quadratic function and its inverse. Consider the function f, where f of x equals negative 2x squared and x less than or equal to 0. Sketch the graphs of the function and the inverse of the function, and the line y equals x on the same set of axes. Solution. By inspection, we know that there is a square relationship between the variables x and y. We can draw the graph of the quadratic function. Sine of the parameter a is negative 2, hence the parabola will open downwards. Y-intercept 0, 0. X-intercept 0, 0. Turning point 0, 0. As q equals 0, note that the domain has been restricted to x less than 0 or equal to 0. Hence we shall sketch only one arm of the parabola. When x equals negative 1, y equals negative 2. When x equals negative 2, y equals negative 8. Let us perform the horizontal line test on this graph. We can see that the horizontal line cuts the parabola on only one point. Hence, it is a one-to-one relation. Let us now determine the inverse of this function. Interchanging x and y, and making y the subject of the formula, we get, therefore y equals plus or minus root of negative x over 2. Since the domain has been restricted to cover only values x less than or equal to 0, we do not include the positive values. Therefore, f inverse of x equals minus root of negative x over 2. Generalizing, we can say that the inverse of the quadratic function is given as y equals plus or minus root of x over a. For domain, x greater than 0, y equals plus root of x over a. For domain, x less than or equal to 0, y equals minus root of negative x over a. We can sketch the graph of the inverse function by restricting the domain to x values less than or equal to 0. If x equals negative 2, y equals negative 1. If x equals negative 4, y equals negative root 2. We can now sketch the inverse of the quadratic function. We can see that the inverse of this function is a one-to-one relation. The function f of x has been reflected along the line y equals x to form f inverse x.
Need more help? Subscribe to our channel. Can't wait that long? Ask Mesky to help you and let the math finally start mathing.